All right, so what we're gonna do is we're gonna talk about fundamental theorem of calculus part 2. The first question we're gonna go. First thing we're gonna talk about that's also on the test. It's gonna be, you guys need to remember what is the average value. Average value is equal to 1 over b minus a, integration between a to b of f of x dx.
What is this lesson called?
No, this is fundamental theorem calculus. I will talk about it in a second. So, but I want to make sure you guys remember this because this is on AP exam, also on Friday's test. So there was a mean value theorem for integral.
The exam was on Friday? Yeah.
Huh?
Test on Friday?
Mm-hmm.
Oh,
It's not that bad. If you do your homework, you'll be okay. Nobody ever need to study for math. You just need to understand math. So integration between a to b of f of x dx is equal to f of c times b minus a. And you're gonna look at those two; they are almost identical. It's that mean value theorem for integral. You are finding the value of c. Finding the value of c. C is gonna be some type of x value. So you want to find the value of that. So let's talk about fundamental theorem of calculus. Let's found it. Mental theorem of calculus. Now you did this for the last few days, which is integration of f of x dx between a to b is equal to big F of b minus big F of a. Do you see that I just do a changing of a non-capitalization to a capitalizing and then insert a b, subtract a? Now I'm going to talk about fundamental theorem of calculus part 2. There we go. Part 2. Now part 2, it's gonna be you integrate it, and so it's like, and a good analogy is like you integrate the orange juice, you get orange, and then you take a derivative of the orange, you go back to the orange juice. Okay. So what I'm trying to say is this: if I have integration of some type of f of t dt, and we're gonna have a boundary. This boundary is gonna be in red, x and a, and also before that, after that, we're gonna take a derivative with respect to x, and this one will always equal to f of x. And you say that's very intuitive. If I take integration of orange juice, I got orange, and then I take a derivative of the orange is equal to the orange juice, and you say, well, that's pretty idiotic. Like, why is he spend time teaching this? Is he stupid? Maybe he is. Who cares?
Why is it f of x instead of f of t?
Oh, good question. I want to FT just want to using a different variable there, and I want to address that because when I integrate it, I'm going to become a new function, which is capital F, and then I'm going to plug in the x, and I'm plugging the a. Now, if most of the time you will see that usually a company will take a derivative with respect to x. So actually end result is going to be in terms of x. So it doesn't matter what you start with when you have a variable as t, it doesn't matter that. Now you're going to say, well, this is a perfect situation. So perfect situation never occur in Mr. Ye's test, right? You don't need to write it down, but never occurred in Mr. Ye's test, ever, right? So what will be Mr. Ye's test look like? Well, he's going to have a question, and he's going to tell you what this big F of x is equal to this. And also, I really don't want to name new questions, so I'm just going to be 1 minus t squared dt. And I'm going to change the boundary. I'm going to put up very, very exciting boundary, for example, sine x, and then cosine of x, and then we say, oh yeah, this is a very cool boundary. We never have a boundary. It's an expression Now, anytime you have boundaries expression, the thing's a lot more fun. Because it could be a semicircle. It could be a semicircle. It's not bad, but we're doing definite integral. So the only way to do that is using trig substitution, and you don't know how to do trig substitution. So yeah, there's a U substitution and there's a trig substitution. And if you want to wonder what trig substitution look like, look at a Sims math essay over there. That's a trig substitution. Yeah, that's just very, very disgusting. You have to deal with trigonometry with the U substitution, which is
Why is it so neat though?
yeah, that's
Like printed on.
that's a sim. And there's a square root of bra. So then you say, okay, well, what is this question asking? This question is gonna ask you, what is f prime of x? And it is a question mark. And you're like, okay, how do I integrate? And the boundary is sine of x and cosine of x, and I want to find the f prime of x. Here's the thing. Since you don't know trig substitution, and you're not going to this year, and if you take double block, you don't even have to, because Mr. Cooper says, I'm not teaching this subject, it's not an AP exam. But it is on Calc 2. So I told them how to do trig integration, even though I had to relearn it myself, and I teach them. So I think that's important because it's going to be on Calc 2. Now, how do you take derivative of this? So first of all, you have f of x. Now I'm going to add a d to the dx on both sides. So I'm going to copy this thing. I'm going to copy. And I'm going to paste. And the only thing I'm going to change is I'm d to the dx on both sides. I take a derivative on both sides. When you take a derivative on the left side, you're going to get f prime of x. Am I going too fast?
Wait, just wait. I don't have copy paste on mine.
Now, you're going to say, Mr. A, I know how to do U substitution. Why can I use U substitution? Here, did you foresee the problem already? If you have U equal to 1 minus t squared, du is a what? Negative 2t dt, right? And there's nothing for you to cancel. So you got a square root of u, and you got a negative 2t outside, and you cannot do back substitution, so there was a lot more issues that way. So you know that thing. But the nice thing is you don't even need to know how to take integration of this. That's a beautiful thing about math. I know there's something in math called Laplace transform. It works very, very similar like this. It's like way above me. I don't understand that. So if you can understand it, go back and look at it. It's by this guy, is an MIT physicist, and he just find a new way to do one part of math. It's called Laplace transform. But that was really interesting, but it was way beyond me, so I don't understand. I can't really explain to you how that works. So what I'm gonna do is I am gonna assume.
Never assume.
You assume, and we're gonna assume this function called g of t. Why g of t, not f of t? Because I don't want to confuse f and g, so I'm gonna use g of t. So assume g of t is equal to 1 minus t squared. And then I will have d to the dx of this. Sine of x of a cosine of x. And I am going to have a g of t instead of that function. I don't really care what happened with g. Now, why did I use different color? Because this part is fundamental theorem of calculus 1. If I ever integrate this, small g of t, what am I going to get? According to fundamental theorem calculus 1.
F of
Not f.
G of sine. G of
It's a capital G or non-capital G?
capital G.
So capital G. So this, I'm just going to kind of move this down a little bit to the next page. So if I integrate this, guess what? I'm going to be big G of sine of x. Does that make sense? Minus big G of cosine of x. Does that make sense? And I'm going to take a derivative after that. And it's equal to f prime of x. So what I did is I did fundamental theorem of calculus 1. I didn't do anything fancy. I just integrate them. I integrate the orange juice, become orange. It's like when we take a derivative, things kind of alter a little bit. Because if I take a derivative to the big G, what am I going to get? What am I going to get?
Little g.
Little g. Thank you. Those people start understanding what is going on. And there is a chain rule. What's derivative of the sine of x?
Cosine.
Cosine of x. Am I going too fast? Minus a g of cosine of x times what?
Negative sin x plus sin.
It's chain rule, right? Again, this chain rule is so important. That's what makes fundamental theorem. It will alter because the chain rule. And so I know g of sine of x because we assume this. If we assume g of t equal to square root of 1 minus t squared, can I just say that's equal to 1 minus sine square of x times cosine of x minus square root of 1 minus cosine square of x times what?
Bro, what's happening? I mean,
Negative sine of x. I just plug in. I plug because I know this is what I assume, right? What is g of sine of x? Well, g of sine of x is equal to 1 minus sine square of x. Because if this is plug in t for t, this is plug in sine x for t. So I just plug in that. Does that make sense?
yes. Actually,
Now, I just need to work it out. What is 1 minus sine squared of x?
cosine squared.
And square root of cosine squared is what?
Cosine.
So you enter to be cosine square of x minus what's 1 minus cosine square of x? Square root of sine square.
Sine times sine. Negative negative.
Sine x sine. This is sine x sine square of x, right?
Yes, one. That's one.
The answer is 1.
What is root one? I guess.
Well, this particular question was in University of Chicago final exam. And the reason why I knew because I have a girl go to University of Chicago. She called me like at like 9 o'clock in the night. I'm like, what the hell are you doing? Why are you calling me? It's like, you're not wrong, Grudge. So she's like, Mr. Yeah, I need your help. I have this question on tomorrow's final exam. I know I studied with you before. You teach me before. I didn't know how to do it. Can you reteach me again? I'm like, please leave me alone, Sarah. Please leave me alone. Why are you calling me at 9 o'clock? But eventually, I was like, she's like, I really need your help. What is this question? I thought it was really cool. It worked out to be 1. And I thought it's really, really interesting. So now let's go back to the perfect situations, right? This perfect situation right here. What actually happened? What actually transpired? And why do I say that's perfect system? Because if I integrate small f, that's going to give you capital F of x minus capital F of a. Now, if I ever take a derivative of this is going to be f of x times the derivative of x is 1 minus f of a times derivative of a, which is 0. Boom, it's f of x. So that's why I went to f of x. Now, but not all systems go back to the perfect. This is a perfect situation. You're never going to have that on my test. You're always going to have something fun.
Can we do like a rerun of what you did with the regular one?
We just stay there.
I'll give you the questions. Since we only have 6 minutes. We say f of x equal to 1 over 1 minus t squared. Integration between e. Oh, what's e? I don't know what's e. Sine of x. Okay, sine of x.
Wait, is it like the actual E or is it just a variable?
Just a e. Just e. You gotta think about what is e. Can you find f prime of x?
Let me see. So getting a little.
If you try to grab like the previous problem, like what even does that even mean, like the boundaries? Like how could you start with those one? Do you understand what
Right now, we are not care about the only reason why we can put boundary is expression, is because we are gonna following with the derivative. Otherwise, it doesn't make sense.
yeah. Does that mean like okay.
Alright,
Otherwise, it doesn't make sense. So for you, you are gonna recognize when this is a expressions, not a constant, then you know usually following with the derivative. Otherwise, it doesn't make sense. You're right. What Daniel says, it doesn't make sense. What does that look like? It doesn't. It just saying says if you integrate and then you take a derivative at following time, that's only time that you can have an expression here instead of constant. Otherwise, it doesn't really make sense.
So I want to ask this question again. Is this E referring to like you know how we have like E of X, like and it's like a 2 point something number? Is this E? Is that E or is it just like a variable E?
E is a most unique number in the world.
Okay, so it's the cool. It's the E that okay.
E is a one special number.
I feel like with every question I get more confused. Like you answer one
Fine,
question.
I'll figure it out myself.
E, if you type in Google, they will tell you.
2.27.
Who
So
would
is
win
it,
a fight,
is
you or
it that
I?
2.27 number or is it
What is pi?
1592?
6579554?
Okay,
Then what's in this?
This is it?
Yeah.
I just think
I got the answer.
I know.
Me too.
I did in my head originally.
Anything after 2 decimal points.
Wait, did that? No.
Yeah.
That's just today.
how do I do
This
this?
is one. We gotta fight. It's like the last one. We gotta fight.
It's not one.
One day can
No,
I
yeah,
go
no,
left?
no.
Huh?
Is it 2?
One day can I go left? Can I get the left on E?
I don't think it's any of the book.
Sure. That's actually a very cool
I
lecture.
don't even know any of the rules that go with E. Like, what do you do?
We're gonna do that too. We're gonna do that with Taylor series. It's actually the same guy did it. Yeah. I actually thought that was a good lesson.
Well, I'm assuming G of.
Don't assume.
Yo, mama gonna be assuming. Like,
No, it's gonna be secant of x.
Mom, I'm sorry. That was
It's the cosine squares on the bottom. It's gonna cancel one the cosine.
Oh, right, yeah.
I gotta take the
No.
derivative of this.
No. You would make it.
What's the derivative?
I don't know. Don't ask. Don't ask. If it's F.
Wait, E is it's a constant, right? So it just becomes 1, or it becomes E, right?
Yeah, like five.
Okay, so it's G of E.
I don't know what's going on.
That's crazy. That's wild.
Do we apply these?
That's crazy.
You know,
Let's walk through this. Maybe.
then what's the derivative? When you're assuming, you're just adding another substitution variable.
Kinda it's like new substitution.
Dear Google.
What does the assume mean?
I'm writing to you this letter.
It doesn't really matter.
Yeah.
So if I integrate this, I'm gonna get g of e, right? minus g of sine of x, right? And I'm gonna take a derivative after that because I'm gonna prime both sides. So that's g of e. E is a constant, so derivative of e is 0.
I knew it.
I gotta go. Well, you just guessed. Oh, look.
I think I'm getting that. Are you gonna go to Elkins?
Are you doing them? Are you following?
Yeah, actually, what I need to do the independent.
Yeah. When you run it off, it makes sense.
I'm gonna bond.
But like when you're first looking at the question, it's so daunting.
I should get.
Like,